Welcome to Spring LIB.
In this exercise, we have a system of pulleys as shown here in the picture, and a block that has a mass MA, which is equal to 50 kilograms, and a force that's applied at point B that has a magnitude of 150 newtons. Our goal is to find what is the speed of block A, after the block has risen by a distance delta x equal to 3 meters. Assuming that the initial speed of the block, v0, is equal to 0 meters per second, that is, the block starts at rest. So in order to solve this, we need first to review how we deal with problems that involve pulleys. Okay, and in doing so, we will be already solving the exercise. So basically, remember that a tension in a perfect string, that is a massless string, that passes through a massless pulley propagates through the whole string. This means that the tension in the green string that's shown here, so the tension at this point, T1 is equal to the tension at this point, which is T2, which is T1, and is equal to the tension at this point. Okay. Now, since the force that's being applied at point B downwards is F, then the tension T1 must be equal to the force F, since the string is massless. Okay. Because basically this happens basically because we have the force F pulling the string down and the force T1 pulling it up. And according to Newton's second law, this is equal to ma, but since the string is massless, then this is equal to 0 because m is equal to 0, which means that F is equal to T1, as we said before. Okay, so this is the basic principle that we're going to use here. First, that the force applied at point B is the force at the green string in the picture. Okay, and also that for perfect strings passing through massless pulleys, the tension is the same all throughout the string. So for the same string, we had the same tension. And we also have tension T2 for the red string here. Okay, so now we can just go ahead and solve the exercise. So basically, notice that at point C, that is at the second pulley here, this one here, the forces that act on the pulley are T1 from the first part of the pulley, and also T1 for the for the first part of the string, and also T1 for the second part of the string. And this is equal to the mass of the pulley times x. But assuming that this is a perfect pulley, the mass is 0. Okay, so I have the two. There's an extra force here. There's also the force that pulls the pulley C down, that is T2, okay, the force that comes from the red string, so I have minus T2 is equal to 0. To be more complete, this is equal to MA, and M is 0. So we have the 2T1 is equal to T2. Okay, this is important. And now we can draw the free body diagram for the block and for the block A. So basically, notice that the string is pulling the block up such that if this square here is the block, we have the two parts of the string that are pulling it up with a force T2. We have the gravitational force MAG that's pulling the block down. And if we apply Newton's second law, we have that 2 times T2 is equal to minus MAG is equal to MA times the acceleration of the block A. Now, remember that T2 is 2 times T1, and T1 is just the force F. So we have 2 times 2F minus MAG is equal to MAA. So the acceleration is equal to 4F minus MAG divided by MA. Now F, the force, is 150 newtons. The mass of the block is 50 kilograms. G is 9.8 meters per second squared, and we have to divide it by the mass, which is 50 kilograms. So the acceleration is equal to 2.2 meters per second squared. Now, if we know the acceleration and we know the initial speed, we can simply use the equation for the velocity as a function of the acceleration. So we have that v is equal to v0 plus a times t. Actually, I'm sorry. It's better to use, in this case, Torricelli's formula, because it deals with velocity, acceleration, and space. So we have that v squared is equal to v0 squared plus 2 times a times dx. v0 is 0. Okay, so we have that v is equal to the square root of 2 times a, so that's 2.2 meters per second squared, times delta x, which is 3 meters. So we want to know the speed of the block after it rises 3 meters. So v is equal to 3.63 meters per second, which concludes our exercise.